Hello, my name's Eric, and today we're going to take a look at a problem that involves finding the solutions to two linear inequalities, each of which is expressed in two variables. Sounds complicated, doesn't it? We're going to use a graphical solution to figure this out, and we have the luxury of seeing that both of the inequalities are written in what's known as slope-intercept form. Okay, it can be more complicated than this. But the general idea is we're going to find all the solutions to this inequality, and they are going to exist in one region of this plane. It's actually what we call a half plane. And we're going to get some color on it. We're going to make them purple. Then we're going to find the solutions to this second inequality, and we'll draw all the solutions to this inequality as green points. If that's confusing to you, I've got a previous video that talks about what it means to be a solution to a linear inequality in two variables. And I've got an explanation of this graphical approach that you're going to see here. So all I'm really doing is I'm using graphical techniques to find where the solutions are at for this one, and then to find where the solutions are for that one. And ultimately, the solutions for the whole system have to be points that make both of these true. And those will be found in a region where the points end up being both purple and green. So that's an overview of what we're going to do, and I'm going to work pretty fast here. So starting with this upper inequality, I have y less than or equal to half x plus 2. The solutions to that are found on one side of a boundary line, and it's a line between where the solutions exist and where the non-solutions exist. And it's pretty easy to draw. We've discussed this in many videos. You start here with the y-intercept. On the y-line is found right here. And you use the multiplier of x here as your slope. And I've got videos that discuss this in more detail if you want to go back and research those. But the slope being 1/2 is telling you to go right 2 and up 1. So right 2, up 1, right 2, up 1. If you can get another point, go for it. Otherwise, come back this way and go left 2 and down 1. Now, the point of this is not to draw a line. I think we did a good job. The point of this is to figure out where the line is and then decide where the solutions are relative to this line, because there's really only two options. The solutions are either above it or the solutions are above or below it. And the reason we're using a graphical technique in the first place is you cannot possibly write down all the solutions. So I have a little guide here that I put in a previous video, and I'll write it down again. And it goes like this. If you see a situation like this, where it says greater than, you want to draw a dashed boundary line and shade above it. And that's not what I have here, but I'll call this style A. Style B is similar to A, except that it includes an equal sign. It's not a strictly greater than, it's a greater than or equal to. You draw that one with a solid boundary line and you shade above it. Style C and D both have to do with less than. In C, I've got y strictly less than mx plus b, and I draw a dashed or broken boundary line like this, and I shade below it, because that's where the solutions are. And finally, the last style would be y less than or equal to mx plus b. This little guide will help you figure out what to do and how to do it right. You want to draw a solid boundary line which says, yeah, the points on the line, they are themselves solutions. And also, everything below that line is a solution. Well, folks, that's what I have here. I have y less than or equal to. Looking right here and looking at style D, you can see I've got the same thing. So that prompts me to go through here and make my boundary line not dashed like this, not broken, but solid through and through. So, and I'm basically communicating that these points on this line they're solutions. They're not just boundary points, they're solutions. And then shading below, I'm telling everybody that points below this line are solutions to this inequality. But points above this line are not solutions. So what I mean by that is, if you go to a point like 3, 1, 3x is 3, y is 1, that's below here. That's a purple point, that's a solution. Whereas if you go to a point like 3, 5, that's a non-solution. So the solutions are purple, the non-solutions are colorless. Let's quickly get this one figured out now. Y is strictly less than negative 2x minus 3. Where does that one start? This one starts at the y-intercept of 0, negative 3. I'm assuming you already have pretty decent familiarity with this, the slope-intercept equation and how to draw it. If you don't, I've got a pretty good video on that you can check out. But anyway, 0, negative 3 is down here on the y-line. The slope is the multiplier of x. It's found right here. That's the slope. I like it when it looks like a fraction, and when it doesn't, I just divide by 1. Okay. Why did I do that? Well, because now I've got two numbers that give me directions on how to get away from here. The number on the bottom means go to the right, assuming it's positive, and it should be. The number on the top, because it's negative, it means go down. If I didn't have that negative sign there, I would have said go up. Negative on the top means go down. Don't worry about the bottom. It always, always, always means to go to the right. So, 1 to the right, 2 down. 1 to the right. Oh, geez, we're out of room already. We can reverse these two things. We can go 1 left and then 2 up. And we stay in line with those other 2 points. So I'm going 1 left and 2 up and just repeating the pattern. And before I do anything else, I go back and look at this. Okay. That compares to style C. That tells me that my boundary line needs to be broken or interrupted, and I need to shade below it. So here's my broken boundary line. I'm telling people that I know points that are on this boundary, they're not really green points, okay? They're just sitting there showing you where the green points, the solutions are about to start. And they're supposed to start below. So that's below here. Now the question is, are we done? When I get done shading the green, are we done? No, not quite, but almost. Okay, the goal of this problem was to figure out points that were solutions to both of these. It's just an exercise in logic. If you're a solution to this inequality, you're a purple point. If you're a solution to this inequality, you're a green point. If you're a solution to this system, you are both green and purple. Well, I've basically divided this plane up into 4 regions. Let's call them region 1, 2, using Roman numerals here, 3, and then 4. Okay, look at 1. It's a wasteland. It's got no solutions of any kind in it whatsoever. No green, no purple, no nothing. Region 2 has points that are purple, but they're not green. Region 4 has points that are green, but they're not purple. The solutions to the system are found down here. And notice that this solution region comes perfectly opposite of where there's no solutions whatsoever. So when you're done with this and you're a little bit confused about which part of this is your answer, one thing you can do is you can go to where there are no answers, and then you can just jump right over the heart of the sort of X that's formed by these two boundary lines, and you can say, oh, okay, my answers are down here. This is where the solution to this system is. And don't forget, these are not solution points, but these are. If you want to get really technical, one last thing you can ask is, what about that point right there? Is that a solution? You'll plug it in and you'll find out it's not. That is not really a green point. That point right there, and I'm talking about, what is that? -2, 1. X is -2, Y is 1. If you plug that into the purple, you'll get success. You'll get a true statement. But if you plug it into the green, you won't. And so you can communicate that that's not a solution to the system either by showing that, by putting an open circle there to show that that's not a solution. Well, that's one example. I may do another video later on this. Have a good afternoon, and I hope this helped you tremendously.